I'm Erik Ringdahl, and I'm the product director at foreseeti. And today I'm going to talk about automated threat modeling and attack simulations in AWS. So just a brief agenda. I'm going to talk a bit about the challenge in cybersecurity, all the mandatory doom and gloom. And then we're going to move on to talking about thinking like an attacker, both in theory and in practice, with a demo of our product securiCAD Vanguard. And then we're going to do some questions at the end. So before we get to the doom and gloom, I just want to remind people that things are actually getting better. We are part of some exciting times in technology in general, but also in cybersecurity specifically. And I mean, the cybersecurity budgets are growing, the community is thriving, and there's some amazing new tooling available, and some amazing strides in AI and ML as well for cybersecurity. And I also saw some, there's a service for quantum computing in Amazon as well. I have no idea how it works, but I saw it, and so there's some cool stuff going on. And of course, cloud services are undeniably convenient, and more importantly, they are better in terms of security than what most companies can do on their own. But no matter how clever the machines are getting, how good these services and applications are, we can't blame them for failures yet. Because we as humans are still the weakest link. And of course, in an age of minimum viable products and moving fast and breaking things, people will make mistakes. So when the KPI is progress and productivity, people will cut some corners. And we have seen that in the rise in data breaches, of course, in the last years. And Gartner even estimates that 95% of cloud breaches occur due to human errors, such as configuration mistakes. So how can we help defenders or developers to understand the consequences of their actions without disrupting this great progress and innovation that we see? And of course, there are many great tools and automation to actually catch these mistakes and your current vulnerabilities and all the local optimizations that you can do. But a lot of this defense is actually failing before there even is a hacker attack, because of how we are trying to understand our world, and that is through lists. And defenders don't have lists of assets, they have graphs of assets. And we should really take a lesson from how attackers tend to understand how this graph works. And attackers actually studied infrastructure as it is, and not as in some kind of inaccurate mental model made out of lists of assets and asset databases and vulnerability scanner. That is not the real world. The real world is a graph. But the attacker actually needs to study this graph or the network piece by piece. So it's a lot of work for them to try to figure out how your environment looks. And the graph here on the slide is actually an AWS environment that we have graphed out. And you can understand that it's fairly hard for an attacker to get all of this information. But you as a defender can actually have the upper hand with full information about your environment. So we as defender needs to think in graphs as well. So what is the graph? Well, the graph is your environment. So how everything is connected all the way from a user down to the hardware that you are using. So it's who can talk to who, what user can do what, all of that interconnectedness is your graph. So how can we make this graph understandable? Well, we can build a model of our graph and try to understand it that way. And simulations and computer-aided design are a key part of most other engineering domains. So let's say you want to buy, or you want to build a supercar. You then build a 3D model of it first. You crash it in a simulation. You do virtual wind tunnels in simulations, all to try to figure out design mistakes or improvements that you can make on your model. And we can actually do the same with our graph and our model. So we can leverage existing data in AWS to actually generate a model of our graph, our whole environment. And there are a lot of data sources available to do this. We can, of course, use the APIs for AWS to describe our environment. We can use AWS config, for example, which will collect basically API calls for you and all the information about your infrastructure and keep track of it over time. There's also CloudFormation and Terraform, which is infrastructure as code, and we can use that data to generate a model of your environment or your future environment as well. And then we can enrich the model with information from, for example, vulnerability scanners, such as Amazon Inspector in AWS, or other third-party vulnerability scanners. So we can get all of that into our model and into our graph. But we also need to adopt the attacker mindset to our graph. And threat modeling is basically about thinking like an attacker. So it's a systematic way and structured way to identify and mitigate security threats in your environment. And typically you do this by drawing on with a pen and paper, or you do it on a whiteboard, or there are some drawing tools as well where you actually draw your threat models. But they are typically very manual, they are labor intensive, and they get complex really, really fast. And they are biased as well, because the model will always depend on the modeler and their opinion about security. And of course, as well, for large dynamic scalable cloud environments, the task is just overwhelming instantly. And typically what you're modeling is very limited scope. So you take one application and you model it and you look at it and you fail to understand how it relates to other things in your environment. And it typically doesn't include software vulnerabilities or IAM misconfigurations either. So how can we then leverage our model to automate this threat modeling process and make it automated and unbiased as well? So just like the crash simulation with our car is dependent on physical laws that you simulate, an attacker is also bound, of course, by the logic and the possibilities of the environment in AWS in this case. So we can use, or we are using an open source framework called MAL, which stands for the Meta Attack Language, where we can formalize these laws for our simulation and our model. And this is an open source project, and you can find it on mallang.org and to start try it out. And I have an example here on the right. So basically you define all the typical assets that you would find in AWS. So an IAM user, your policies, your statements, your virtual machines, your containers, everything, S3, DynamoDB, all the services that you find in AWS. You define them as assets to build your graph. And then you also include attack steps and defenses. So these are the paths of the attacker in your graph. So that is how we automate the threat modeling part, is we define the threats in the specification, and then we can automatically generate this big attack graph based on the model. And of course, or not maybe of course, but a lot of the attack steps will actually be legitimate actions in AWS. So if you assume the identity of an IAM user, you will be able to do all of the actions that is allowed on that user. There's no hacking involved in that part. It's just the logic on AWS. The same with a network reachability, for example. It's also mostly logic that is used by the attacker. So there's not much hacking involved in that sense. So to be able to use this graph, because it gets very big, as we saw in the picture earlier, it gets really big and really complex fast. So we can actually use probabilistic inference with Monte Carlo simulations to calculate the attacker's shortest path in our graph. So typically from the outside to our high value assets, but it can also be an insider trying to get to high value assets as well. So with the simulations, we can find the shortest path through this complicated and complex graph. And these shortest paths, or critical paths as we call them, they will then expose the weaknesses, your misconfigurations and choke points in your environment. So the attacker will always take the path of least resistance and the path that is easiest to hack, to reach to get to your high value assets. And this will, of course, also expose potential mitigations. So what can we do to stop the attacker as efficiently as possible? And as I mentioned earlier, we can also include, for example, vulnerability scanner data in our model. So with the shortest path simulation or the calculation, we can actually see if the attacker is able to exploit any of these vulnerabilities, and if they are worth our trouble to patch. Of course, you should patch everything, but there have to be some kind of prioritization. And we can expose the vulnerabilities that are actually used by the attacker in our simulations and that are usable at all. And we can quantify all of this and the risk of successful attack in our simulations with a metric we call time to compromise. And that is basically the probability of success over time in the Monte Carlo simulations. And the great thing about probabilities is that we can also include uncertainty and potential future threats. So it's not just about your current misconfigurations or mistakes or vulnerabilities. It's also about what can happen next. What if I fix all of this? There's always a threat that something new would happen. There is a new vulnerability that we don't know about, or let's say that your users are phished for their access keys, or a user might be pushing their access keys to GitHub, for example. All of these threats are probably not threats at the moment or risks at the moment, but they will probably be later on. There is a risk that they will be exposed. So we can include that in the simulation. And if this sounds very complicated, we have developed an application for this, of course, and it's called securiCAD Vanguard, and it's available at Marketplace right now, from today, I think, yeah. And securiCAD Vanguard then enables you to automatically simulate attacks on virtual models of your AWS environment to find, prioritize, and mitigate weaknesses before an attacker is able to do it. So in short, we generate the model of your environment, we simulate attacks on that model, so we will never touch your AWS environment. And with the help of that simulation, we can then find and prioritize weaknesses in your environment. And as I mentioned, we are now available in Marketplace, so you can go check it out after the webinar. And then I'm going to jump into a demo of securiCAD Vanguard. Let's see. So, yep. So this is securiCAD Vanguard, and I have, of course, signed up in Marketplace and got an account, so I can sign in here. And this is offered as a service, so you don't have to install anything or download anything to run it. So for us to, or for the tool to be able to analyze your environment, you of course need to provide it with data. So the options we have right now is that you can provide the tool with access keys, or you can download a script and collect the data locally and then upload a file to Vanguard instead. And we will provide the opportunity to use cross-account access within a few weeks as well. So if you provide your access keys, you basically let Vanguard read your environment and fetch data from there. And we can also include data from Amazon Inspector, so we can fetch vulnerability scanner data directly, or you can provide data from a third-party vulnerability scanner as well. I'm going to show you the AWS CLI script way. So this is where you download a Python script that will collect all the data for you locally, and then you can upload the file yourself. And this is the recommended way for us, so you don't have to provide the tool with any access keys. Of course, we don't save anything. Vanguard doesn't save any data or any keys, but this is still the preferred way right now before we get the cross-account access roles. So I have done run this script, and I upload the file here, and then I also have some third-party vulnerability scans that I'm going to upload. And then we hit configure. So all that you have to do as a user when using Vanguard is to provide the data, of course, but then you also have to assign high value assets. So what is important to you in your environment? So we can select, for example, an RDS or any EC2 instances or S3 buckets, for example. And there's actually a tool in Amazon, in AWS, called Macy, which can actually find buckets with high value information in them automatically for you. So you can check that out as well. But I know what is important in this demo environment, and this is actually a actual demo environment that is running in our lab account. So I will pick a few high value assets here, and we hit next. And then we get to choose the attacker profile. So what is the kind of threat that we are worried about? We have state-sponsored, we have cybercriminal, and opportunist. And this will tune the probabilities in the simulation. So how likely, for example, is it that an attacker will phish your users, for example, or be able to develop new vulnerabilities in the simulation? And of course, state-sponsored attackers are the most capable ones, and they will typically be able to do spear phishing attacks and things like that. But for the sake of the demo, I will pick the middleman here, the cybercriminal, and then we are ready to simulate. So now it's running the Monte Carlo simulations on our model, and it will have no contact with your actual AWS environment, so there's no worry about availability or anything like that with your actual environment. So now the simulation is done. We can start off by looking at the model and our actual environment. So this is our demo environment. So we have a few EC2 instances, a few databases. There's some VPC peering. We have a few users, a few groups, and this is not just a visualization of our environment. This is actual working model. This is a digital twin of your environment that we have generated. And if you remembered, I also included some vulnerability scanner data, and there is inspector data here as well. And if we look at this view, it might be a bit hard to see, but these columns are actually all of the CVEs or the vulnerabilities that the scanners have found on the different virtual machines. So there are, I think, over 100 vulnerabilities in our environment. These are actual vulnerabilities reported by vulnerability scanners. So this is our environment that we have simulated. Let's go back to the report. So the first thing that we are faced with is a brief overview of the high-value assets that we have. So there's 4 of them right now in this simulation. And we get an indication of how easy it was for the attacker to actually compromise this asset. So we can, for example, look at the customer web server here. There's an internet-facing virtual machine, basically. And we can look at the time to compromise, as I mentioned earlier. So now this graph is almost not visible because the attacker is succeeding all of the time within a day, basically. So it's super easy for the attacker to actually compromise this asset, and we can look closer at why that is. So this is one of the critical paths, or the shortest path that I mentioned earlier. So this is the shortest path from the attacker, and its entry point, which is the internet by default, to our high-value asset, which in this case is the web server. So we can follow the steps of the attacker here, and what configurations the attacker has used to actually for example, transmit requests to a load balancer, then which are forwarded to an Apache struts. And what we can see here is that there is a vulnerability here that the attacker is able to exploit in the most critical path. So this is the easiest way for the attacker through our environment. So the attacker is able to gain code execution and basically compromise the asset, the virtual machine instantly. So this is the most critical path, or the shortest path from the attacker to our high value asset. But we can look at other paths as well. So the paths that are still possible, but less likely. So these are all the paths which succeeded in the simulation for the attacker. But they are less likely and will not happen as often in our simulations. But these are all the ways the attacker can succeed in our simulation. And the dotted lines here are, as I mentioned earlier, we also account for uncertainty and potential risk. So we have an actual vulnerability here, but the second most dangerous thing in this simulation is that there will be a new vulnerability on Apache struts in the near future, for example. So the attacker is able to gain code execution from that as well. But they are dotted because they are made from assumptions. So in this case, the most critical path is, of course, the critical vulnerability that we have the attacker is able to exploit. And based on the critical paths for all of our high-value assets, we can then generate choke points, which is basically where the attacks converge in our simulation. So where are the weak spots in our environment, or which assets are the attacker passing by to get to all of our high-value assets? So for example, here we see Apache struts. It's a weak point in our simulation. Also the security group here that is allowing this traffic, we can look at that, and we can actually look at that security group in our AWS account directly and see if there is any issues with that security group directly in AWS. So if we go down a bit, we also have something we call threat summary. And these are ranked threats. So these are the top threats in the simulation that will affect most of your high value assets. So on the top here, we see the CVE, the actual vulnerability on Apache struts here on this virtual machine that we call customer web server. And it's accessible to the user because of this security group. And we can see other types of threats here that are allowing the attacker to succeed. Is, for example, we have a user called Adam here that is vulnerable to credential theft because Adam has active access keys on his accounts. And we can see this is dangerous because Adam also have administrator access in this model. So all of these threats will eventually lead to that we have such a high risk exposure in this example. So this was just a brief demo of securiCAD Vanguard. You can go into Marketplace and try it out yourself. It's available now. I think we're going to move over to some questions.
Yes. So, yep. First one. Can I run this on-prem?
We have a product called securiCAD Enterprise, which you can run on-premise. You can run it in your own AWS environment, and it features everything that you saw in Vanguard today. And you can even use it air-gapped on your own laptop.
Can this be integrated, or how can this be integrated into my CI/CD pipeline?
So we will provide SDK for Vanguard on our GitHub soon. So you will be able to integrate Vanguard into your pipeline and programmatically access Vanguard that way. And of course, in enterprise, we have a documented API as well, so that it's fully you can use that as well for automation.
And can I manually make changes in the model as well?
Yeah, you can make changes in the model and actually try out mitigations. For example, remove a security group or make changes in our modeling tool in securiCAD Enterprise. There's a question here on the chat as well. I'm wondering how many different AWS serverless applications does Vanguard analysis support know about? So right now we support Lambdas. So all the information basically that we can get from AWS and the services that we support right now, we can get information from. We don't have information about what's actually running in the Lambda, but from the simulations point of view, it's more important what kind of execution rights, for example, the Lambda has and who can trigger it. And that we will include in our simulation. So
how customizable is securiCAD Enterprise when it comes to building custom components? For instance, login with smart cards.
Yeah, so as I mentioned, we use the meta attack language, and with that you can define your own language completely. So we support your own custom languages in securiCAD Enterprise. You can basically model anything that you want, and of course you can also extend the languages that we support as well.
Thanks, Erik.
Can it be used in Azure? Soon. We are working on the Azure feature. Yeah. Thank you.